Hello students, today we will discuss the vector calculus of your physics syllabus, the first chapter. So the topic is representation of a vector, some important definitions about vectors, resolution of vector into components, product of two vectors, concept of gradient of scalar field, divergence and curl of a vector field, and line integrations, surface integrations, and volume integrations. So these are the topics that we will discuss in some videos, and the textbook is you have to follow, that is Engineering Physics by Sujay Kumar Bhattacharya, and for reference book you can consult or you can see or read Theory and Problems of Vector Analysis by M.R. Spiegel. So before going starting this topic, first we have to discuss or we have to know that why this vector calculus is important in physics or in BTech engineering physics. So we all know that the concepts of mechanics are essential for understanding the world around us. That means in classical mechanics, we are usually concerned with some physical quantities such as displacement, velocity, fields like electric field, magnetic fields, gravitational field, etc. So in translational motion, concept of force, linear momentum, translational kinetic energy, these are the important parameters. Whereas for rotational motion, the same analogous concepts like torque, angular momentum, rotational kinetic energies, these are the most important things. To understand the laws and enjoy the physics, we have to know some basic knowledge. We have to know the basic knowledge in calculus. So the vector calculus, it is one of the mathematical tools where the differentiation and integration plays an important role. So vector calculus, all we know that it is a branch of mathematics concerned with differentiation and integration. So in differential calculus, we learn how to study the variations and find the rate of changes of different physical quantities. That means if we want to determine the velocity, so it is the rate of change of displacement. So velocity is equal to ds dt. So to know any particle's velocity, we have to know the differentiation. So that is why the vector calculus, though it is a mathematical tool, it is widely used in physics. Now we will recapitulate some basic things, that what are scalar and what are vector quantities. So the scalar quantity is, that means it has only magnitude, no direction. An example is length, area, volume, speed, work, power, so on. And the vector quantity is, that means it has both magnitude as well as direction. An example: displacement, angular velocity, linear velocity, acceleration, torque, electric field, etc. Now we will discuss some different types of vectors. So first we will discuss the zero vector. That means the starting point coincides are the same with the terminal point. So starting point and end point will be the same. That means its magnitude is 0, but it has direction. That is zero vector or null vector. And unit vector is, that is the which has a magnitude of unit length. That means a vector by magnitude of a vector. That is called unit vector. Now rectangular unit vectors means in 3D coordinates. All of you know that we have x, y and z coordinates. So it is denoted that for x coordinate, this is I cap unit vector, and for y direction this is j cap, and for z direction there is a k cap unit vectors. And what is position vector? So suppose in any three-dimensional Cartesian system, there is a point P or particle P, and it is its points is suppose A, B, C. So the r vector is equal to a I cap plus b j cap plus c k cap, and the unit vector r cap is equal to r vector by mod r. So this is referred to the position vector. Now co-initial vector means all the vectors are starting from a same point. That means OA, OB, OC, all these A, B, C three vectors are starting from these O vectors. Now the like and unlike vectors. Like vectors means the two vectors or three vectors having same direction, they are called like vectors, and those who are in opposite direction, they are unlike vectors. And what are equal and opposite vector? That means equal vector means having same direction and same magnitude. That is called equal vector. And whatever what is opposite vector, that means having same magnitude but opposite in direction. These are called opposite vectors. Now coplanar vectors. This is very important because this is one concept that three or more vectors lying in the same plane or parallel to the same plane. These are called coplanar vectors. And collinear vectors, they are also known as parallel vectors. That means vectors which lie along the same line or parallel to a line. So they can be same direction or in opposite direction, but they are parallel to each other. Now equal vector and equal vector I have already discussed. Displacement vector. Displacement vector means that if a point, that means a particle is moving from a to b position, then ab represents the displacement vector. And this is suppose a vector is from origin, this is r1 vector, and for b vector this is r2 vector. So according to the vectors triangle law, that AB, that is delta R, is equal to R2 minus R1 vector. And negative vector, it is also known as opposite vector. Now reciprocal vector. Reciprocal vector means suppose there is a one vector A. So the reciprocal of this A vector, that means the magnitude, the direction is same of the A vector, but the magnitude is equal to the reciprocal of a given vector A. That means reciprocal vector is equal to the A cap, that means the unit vector along A vector given vector by its magnitude, that means mod A. Now polar vector, it is associated with a linear motion in a particular direction, and it changes its sign under inversion or reflection. They are called polar vectors. That means the linear velocity, linear momentum, force, uh, these are, their signs are inverted using or changes when it will be reflected by any mirror. Now axial vector, it is associated with the rotation about a certain axis, and it does not change its sign under reflection or inversion. An example is angular velocity, angular momentum, torque, any rotational, any quantities associated with rotational motion. Next, what are scalar fields and vector fields? So all of you know that is what is scalar quantity and vector quantity. Now we want to discuss what is scalar field and vector field. So first we have to know what is field. So in physics, field is a physical quantity which is assigned to every point in space, generally space time. So it can be independent of time or dependent of time. And what is scalar field? So when a scalar quantity is assigned in a certain region of space and it is continuous throughout the space, these are called scalar field. An example is time, temperature, volume, density, any scalar quantity. That means it has only magnitude, no direction. And it is assigned to any region of space. So scalar field, it can be temperature dependent or time dependent or time independent parameters. Now Vector field. Vector field means which has both magnitude as well as direction, and it is assigned to any region of space, and it is continuous, but it can vary at different space points. An example is electric field, magnetic fields, gravitational fields, etc. Now today we end this lecture here. The next topic will be discussed in the next video. Thank you.